I'm Miss Ulrich, and in this video I'm going to teach you about domain and range on a set of ordered pairs. So domain and range is a way to describe a function set and the ordered pairs in the function. Now remember, a function is a set of ordered pairs, x and y, such that no x values are repeated. So remember how at the beginning of the year I told you that silly joke about how you can't date your siblings' exes? Well, that's one way to remember how to tell if it's a function or not a function. First, you need to look at the x's in each of the situations and see if they repeat. If any of the x's repeat, then it's not a function. If they don't repeat, meaning none of the x's are the same numbers, then it is a function. So it's fairly simple to remember these. The domain are all the x values or the independent variables in the function. So what we look for are the x's, and each of these are our x's. So remember, the x's are the first number. So when I'm writing my domain, I'm simply listing the first number in each of these. So we have 0 to 3. Now generally we do write in order from least to greatest. So we start with the smallest and then go to the biggest. Now the range are all the y values or the dependent variables. So when we look at a set of points, we're looking at the second number in each of these to determine our range values. So again, we write in order from least to greatest. In this case, it would be 1, 5, and 6. Now, the domain and range are always written in parentheses, and a comma is used to separate each number. Okay, so let's look at several examples now where we identify the domain and range and determine whether it's a function or not. So remember, domain are all the x values. So these are our first values in each of these set of ordered pairs. So remember, we write it in order from least to greatest, and we're going to separate it with parentheses. So we have 0, 2, and 4. Well, that is in order from least to greatest right now, so I'm going to write 0, 2, and 4 in parentheses. So this is my domain. The range, remember, are the y values, and they're the second number in each of these parentheses. And again, we write them in order from least to greatest. So we have 1, 3, and 5. That is in order, so we put 1, 3, 5. And this would be our range. Now, to determine if it's a function or not, remember, none of our x's can repeat. Well, none of them repeated, so therefore it is a function. So I'm going to put yes, it is a function. Okay, and the second one, again, the domain are all the x's. That's the first number in each of these set of ordered pairs. So here we have 3, 4, and 3. Right away, I want you to notice that they repeat. So therefore, it is not a function because our x is repeated. Now, because they repeat, I don't need to write them twice. I'm just going to write, I'm just going to write 1, 3, and then a 4. Please ignore that. Sorry. Okay, so we have 3 and 4 for our range, and then, for our domain, and then our range are all the y values. So again, we have our second number in each of these. That's 6, 2, and 9. So I'm going to write them in order from least to greatest. So we're going to start with 2, followed by 6, followed by 9. And this would be our range for this one. Now let's look at domain and range if we were given a graph of it. The easiest way to do domain and range on this one, if we are given a graph, is to actually list out the coordinate points, and then we have exactly what we just looked at. So that's what I'm going to do here. I'm going to start with number 3. I'm going to list each of these points out to the side so that I know their coordinates. So let's start with this point right here. So this point is at -3 and -3. Okay, then let's go to this point here. That point is at 1, 1. And then this point down here is at 2, -3. Okay, so if I'm listing my domain and range, then my domain, remember, are all the x's. So that's the first number in each of these. And again, we write it in order from least to greatest. So we have -3, 1, and 2. So I'm going to start with -3, followed by 1, followed by 2. Okay, the range are all the y values. So that's the second number in each of these values. So we have -3, 1, and -3. Now, notice the y's did repeat, but that doesn't matter whether it's a function or not. I only look at the x's to determine if it's a function. Because the y's repeat here, though, I am only going to write that -3 one time. I don't need to say it twice, so I'm just going to put -3, 1 for my range. And then to determine if it's a function, none of my x's repeated. Remember, that's what I'm looking at to determine if it's a function. Since none of the x's repeated, it is a function. Now, there is one more way to determine if it's a function on a graph, and that is to use what's called the vertical line test. The vertical line test basically says that I should be able to draw a vertical line through any point on the graph and it not touch more than one point on the graph. And if you notice, I just drew a vertical line through every single point and it only touched one point on each of these. So therefore, it is a function. All right, let's try it again on number 4. So again, I'm just going to list these points out. So we'll start with this point up here. This point is at -1 and 3. Let's do this point down here. That point is at -1, -2. And then finally, this point over here is at 4 and 1. So when I list my domain and range again, the domain are all the x's. So that's the first value in each of these. And we have -1, -1, and 4. So right away, I want you to see that the x is repeated, meaning that it is not a function. Okay? Now, I am going to only write that -1 one time. There's no need to say it twice. So -1, 4 is my domain. And then for my range, we're looking at all the y values. So those are the second value in each of these. So we have 3, -2, and 1. I'm going to start from least to greatest. I'm going to start with -2, followed by that 1, followed by that 3. So -2, 1, 3 would be my range here. Now we already determined it was not a function because the x is repeated, but I also want to show you that vertical line test again. The vertical line test said I should be able to draw a line through any point on the graph and it not cross through more than one point on the graph. Now this line here is fine because it only crosses that one point, but this vertical line crosses twice. It touches here and here, therefore meaning it is not a function because it does not pass that vertical line test. So one thing you have to look for with domain and range is it reasonable? Domain and range, a lot of times we're going to look at in problem situations, and anytime you're given a problem situation, you have to determine, does that make sense for the domain and does that make sense for the range? So let me give you an example of that. Let's say I'm talking about the number of shoes that you have in your closet. Well, first of all, we know that if I'm talking about shoes, when I buy a pair, it comes with 2 shoes. So one pair has 2 shoes in each pair. So when I talk about the domain for this, I'm talking about the number of pairs that I would have in my closet. So I could have, 0 pairs of shoes, 1 pair of shoes, 2 pair of shoes, 3 pair of shoes, so on. That would be represented like this. Here's 1 pair, 2 pair, and 3 pair of shoes. So it would only make sense to have a positive number, and it could be any number, not a fraction obviously, but any whole number that's positive. I could have, 1 to 100 pairs of shoes in my closet. Now let's go with the range for that one. The range would be the number of shoes that I actually have, talking about that it comes in a pair. So this would mean I have 1, 2 for that first pair. This would be 3, 4, and then 5, 6. So if I have 3 pairs of shoes in my closet, I actually have 6 shoes. So it would only make sense for this number, the range, to be an even number since we get 2 shoes for each pair. So I could have 2, 4, 6, 8, 10, 100, 200, so on, as long as it's a positive, whole, and even number. So again, check the reasonableness and whether it makes sense. All right, so let's look at these last few questions where we look at domain and range from a data set actual problem situation. So number 5 shows us the data that was collected during the last week in July and the temperatures each day that week. So when we talk about the domain, remember the domain are all our x values. And when we look at a domain in a table, we're looking at the x's, and that's the top number here. So we're actually talking about the date. So the domain are all the days of the week. So we'd have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And again, we'd write that in parentheses with commas separating them. So now for our range are all the y values. So that's going to be, in this case, our temperatures. And we do want to write it in order from least to greatest. I'm also not going to repeat any numbers. So my range would be 95, 96, 97, 98, and 100. And although my 96 repeated and my 98 repeated, I only wrote them once, and I did write them in increasing order. Now to determine if it's a function, again, we're looking to see if our x is repeated. Well, this is one of those where does it make sense? My days of the week. Should my days of the week repeat within 1 week? No, of course they shouldn't. So yes, it would be a function because I'm not going to have 2 Mondays or 2 Tuesdays in 1 week. So this would be an example where you need to check your sense of it. All right, let's take a look at number 6 now. So it says Dale kept track of the number of sacks that he made for each football game, and it asks us again to determine the domain and range. So again, domain are all the x values. That's going to be the top values in my table. So the number of games. So again, when we look at this, we're going to look at all of the numbers, which looks like 1 through 10. We're going to write it in increasing order, and we're not going to repeat any numbers. So my domain would be numbers 1 through 10 in that order, separated by commas and in parentheses. And that's the number of games, or game 1 through game 10. Now, the range are all the y values, so those are the second number in the table. And again, this is the number of sacks that I made, so I'm going to write it in increasing order from smallest to largest, and again, I'm not going to repeat any numbers if they in fact repeat. So my range would be numbers 4 through 13 in that order, each separated by a comma in parentheses, and none of them did repeat here. So again, to determine if it's a functional relationship, we look at our x's only and see if any of our x's repeated. Well, again, this is one where we need to determine whether it makes sense or not. Should we play game 1 more than once or game 2 more than once? Well, the answer would be no, so of course it would be a function because none of my games would repeat. I wouldn't play it more than one time. Hopefully that helped you to give you an understanding of how domain and range can be used to describe a graph. Keep watching for more videos, and remember to ask questions in class.